Did you start the 5 stream? You have to reload it.
Okay, guys. So let's get started. Okay, oops. So let's get started. We're gonna get started right here. So we were doing parabolas, and we were doing the self-check. Okay, so let's get started. Okay, so we were right here on number 5. Okay, so let me open my participants sheet. So here. So let's see. Yeah, so I guess Akil is going first. So Akil, you can do number 5.
I was only here for the last couple of classes, so I do not know what I have to do.
Okay. Okay then. There's okay. Well, okay. I guess just watch for today. I guess. So Middleish, can you do number 5? Do you remember how to do number 5?
Number 5?
Yeah, number 5. Hello? Middleish, you're muted.
Yeah. The answer would be wait.
Huh? ఏంటి? What was your answer? Okay, so I
My
think
answer was 3 holes.
3-0. Okay. Oh, well, let's find out if that's right. So the first thing we're gonna have to do is fix up this equation. But before that, okay. So yeah, the first thing is we're gonna have to fix up the equation. So what we have to do is we have to multiply both sides by 2 because there's a 1/2 on this side. So to cancel it out, we need to multiply by 2 on both sides. So we have 2 right here, cancels this out, times 2 right here. And this whole equation becomes y plus 6 is equal to 2 times x plus 4 squared. Okay, then you can subtract 6 from both sides, and this becomes y is equal to 2 times x. Actually, I'm just going to erase this, and erase this, and yeah, that's what we have left now. Okay, so yeah, we got this. So this is in the perfect vertex form. This is in the perfect quadratic vertex form. So now we can, this is h, this variable right here is h, this is k. And if you remember from yesterday, the like vertex is h, comma, k for both vertical and horizontal parabolas. So if we get the eraser and erase this, we can get the mouse and we can type our answer in, which is 4, -6. Okay, so I think we're gonna have to review the. I think we're gonna have to review what we learned yesterday a little bit. So here it is. It's gonna load for a little bit. So does anybody know if the live stream is working?
Yeah,
No, it's not working.
it is.
Okay.
Well, it's showing me like the OBS studio.
It is? Okay.
The live stream that is working.
Ah, okay. That's good.
It's still there.
Can you like see what what's happening on the screen?
Oh yeah, it's moving. I just paused it.
Oops, I think it's gonna load a lot because there's 2 screen shares going on, so it's gonna be very laggy. Okay, so basically, so let's look at the parabolas. Yes, this is where we were, and this is what we need. So if you see here, this is parabolas, and so what a parabola is, it's just a like a U, okay? So it's like this, if you see, and it has a lot of properties. I think it's like 4 properties. One is the focus, another one is the vertex, axis of symmetry, and directrix. Okay, it has all those, and also it has the latus rectum, which is like this line from going here and here. It passes through this point. So yeah, then we can. So here are all the equations or formulas, whatever you want to call them, to get each of these properties. See, length of latus rectum is 1/8, and you want to be looking at this because this is the vertical parabola, which is what most parabolas are. They're vertical, like this one. See, this one is going like up or down. So yeah, so this is like the generic parabola formula, or not formula. It's the standard form. This is the form of the equation for a parabola, and this is the vertex. So yeah, here's the vertex. Axis of symmetry is right here. This is what the axis of symmetry is for vertical parabolas. Here's the focus, which is this point right here, as you saw. And the directrix, it's here. The directrix is like the equation of this line. If you want to find the equation of the directrix, the directrix is this line right here, the dashed line that you can see right here. So yeah. So let's clear the screen and let's go on to the BYU. No, sorry, not the BYU, like the problems. So here we go. This is here. Then we can move this over here. Okay, so that's how you get the vertex and stuff like that. So express the equation 3 blah blah in the form. Okay, so this is asking you to basically like make this equation look more like this equation. So right now it looks a little bit.
Can you go onto that website?
No, this doesn't have public access. It's not publicly accessible.
Wait, you made this?
No, I didn't say that. I just said it's not publicly accessible. I'm not gonna say much more than that. So this is, you have to like kind of pay for this. Okay, so no, you can't. It's not gonna work. Okay.
What is it called?
It doesn't matter. Okay, so Neil, why don't you do this problem since you're super interested in this?
Exponent, which is 2, equal to y plus 9 in the form of. Yeah, I don't get this.
Okay, so basically this is the quadratic thing standard form. This is the quadratic equation standard form. So sorry, not standard form. This is the vertex form. So you have to do some algebra to make this equation look more like this. Look more like this equation right here.
Oh, is
Okay.
that even possible?
Yes, it's very much possible. I was just about to do it. So right now, as you can see, this equation looks a little bit like y plus 9 is equal to 3 times x minus 1 squared. This is exactly what this has, except like the equation is like a little bit switched around. So that's not going to really change anything.
The value of y.
Yeah, you have to solve for y basically. So what do you have to do to make y alone?
So, if y plus 9 is equal to 3 multiplied by x minus 1. Take away 9 and then y.
Yeah, good job.
Can't the problem be y? Can't the problem be y equals 3x minus 1 squared minus 9?
Yeah, that's how you do it. Yeah, good job, everybody.
Okay.
You have to subtract 9 from both sides. Okay, do you understand that, Neil?
Yes.
Okay.
And that turns to the form y equals a x minus 8 squared plus a.
9 with 3 times x minus 1 and 9 and 2.
Okay, so this is we got this equation into this form, which is what we want. So now it's asking us to identify a, h, and k. So if you look at these variables right here, there's a right here, h right here, and k right here.
Oh, so a is 3. Then.
Yeah, good job. Yeah,
And
keep going.
H is 1. Oh, and then plus k. Oh. I have a question.
Yeah, what's your question? Yeah,
Oh,
what's?
that's green.
Wait.
Easy.
Okay, Neil, can you please mute yourself? Someone has a question. Okay, what's your question?
So in the equation that you got, so you took away the 9 from the right and you added to the next side. But then it says plus k and we're subtracting 9.
Yeah.
Does that change anything?
Yeah. So yeah, normally if this was an addition sign, then the value of k would be 9. But since this is a subtraction sign, the value of k is negative 9. See, if this was a plus, then the value of h would be negative 1, not
Wait, but in the formula,
not 1.
you put plus 9 in the formula. The formula you boxed, you put plus 9.
Okay, Siddharth, you're cutting out a little bit on my end. I don't know if it's happening to anybody else, but it might be just because I'm like sharing the screen
It's
once.
happening to me too.
Yeah. Okay. Good.
Oh, okay, I'll check my machine.
Okay. So. Okay. So k is like we said before, negative 9. So that's the answer. You can't really check all of your answers until you like finish this whole thing. But yeah, that's how you do it basically. So let's see. Participants list. Okay. So, Namrita, do you want to do number 7? Okay. So I guess just watch then. Try to understand some stuff. If you don't understand, then just ask. It's fine. So let's go on to Ritvik. Why don't you do this number 7? Ritvik, why don't you do number 7? Okay. So let's go on to Rohanatavisa. You can do number 7. I don't think you were here yesterday either, but
Yeah, I wasn't.
okay. So Satvik.
I wasn't here yesterday either.
Okay. So I guess this goes to Siddharth then. Siddharth, you can do number 7.
Okay. Run equation for parabola, vertex, for reflection of Is it number 2? Like y equals no. I mean, is it number 4? Y equals 116 x minus 4 squared plus 6.
Okay. Well, how did you get that number?
Well, the equation for finding the vertex is 16 a. Was it? Yeah, I think it was a, and x minus a squared plus k.
1/6
And that
A?
formula is almost
Wait, which formula are you talking about exactly?
I'm talking about
This one?
I'm talking about the first one, form an equation.
Oh,
Form
okay.
of an equation.
Okay. Yeah?
Yeah, and I was talking about the vertical parabola.
Yeah. Okay.
And in this case, that's what it showed. And there's only 2 options that show the thing. And from there, I chose the one that has positive 116.
Why? Why did you choose the positive 1/16? I'm not saying you're wrong. I'm just asking why. I actually don't know if you're wrong or right yet. Okay. So it says it has a focus of 4, comma 10. So as you can see, the focus of this and this are the same. So we can refer back to here to know that it's a vertical parabola and it's not a horizontal one.
Oh yeah, the formula for a focus was a plus 1 over 4a, right?
K plus 1 over 4a. So you can use this formula to like calculate the value of a. And so if you calculate that, a would be something like 1, okay. A would be something like 4 times, what am I talking about? Okay, so A would be 4 divided by 1 over 4, and that is, I guess, 16. No, I don't think so. Okay, let's see. So that's 1 over, so 1 over 4, A is equal to 4. Okay, right? We know that, right? So we can do 4 times 4, and we get 1 over A is equal to 16. So we can flip this upside down, and it's going to become A is equal to 1 over 16. So yeah, it's positive 1 over 16. And this is going to be negative 4 and 6. So yeah, you're right. Even though you guessed it, you got the right answer. So yeah, good job. Okay, so let's go on to number 8. Number 8, I guess, goes to middle-ish. Can you do number 8?
Yeah. So the answer is y.
Wait, what is the question asking you for, first of all?
Find the vertex and length of the lattice rectum of the parabola.
Yeah, so from that you can tell that it's asking you for the vertex and the length of the lattice rectum. So do you need me to go back to the slides?
Yeah.
Okay. So if we go back here and we present this and we wait for a little bit to load. Okay, there we go. So the vertex is right here and here, and the length of the lattice rectum is right here. And these A and H comma K values are in this equation or this equation. So do you want me to go back to the okay, so we're gonna have to start the meeting over again. So here we go. Where's Zoom? Okay, here it is. Sign in. Let's go. So for those of you who are watching the live stream, chat if it's working.
What just happened? Yeah, hello again.
The meeting, yeah, the meeting ended. That's what happened.
Exactly.
So,
Why can't you just do unlimited time?
because then I'd have to buy Zoom, basically.
You just kick me out of the meeting.
I didn't do that. The meeting just ended. So Zoom has a 40-minute time limit. So yeah, that's what happened. 60 minutes would be better. 60 minutes would be better. Because it's like a full 1 hour. 50 minutes was on the Cisco WebEx. So, I'm waiting for... Okay, it seems like everybody's back. That was quick. Okay, so, let's keep doing this. I think... Let's see. I think it was... I forgot who it was. Who is it? Middle... Yeah. No, I think it's the... I think the meeting ended because of the 40-minute time limit. But yeah. So... Yeah, middle issue. Yeah. What's so funny?
Yeah, you can go. So the vertex is 4, 1, and length of the lattice rectum is I'm pretty sure it's 16.
Okay, it's actually 5, because if you remember from the slides said that the length of the latest rectum is 1 over a. As you can see here. See, it says 1 over a. So 1 over a, let's go back into here, and let's implement that. So a is this, right? So if you do...
And you have to put the denominator.
Not really. So what you're doing is dividing 1 by 1 over 5. So basically what you're doing is... Let me get my drawing tool. Okay, so you're doing 1 over 1 over 5. And so this flips the fraction upside down, and it multiplies it by 1. And so that equals 1 times 1 over 5. Sorry, not 1 over 5, it's 5 over 1. 5 over 1. Well, it's supposed to be a 1. Okay, it doesn't look like a 1, but it's supposed to be a 1. So 5 over... So anything over 1 is still that same thing, and 1 times anything is still that same thing. So 5 times 1 is 5, and 5 divided by 1 is 5. So that's why you get 5. Okay, do you understand? Okay, so... so let's go on to Manya. Manya, you can do number 9. Number 9. Hello, Manya. You're muted. I can't hear you. Can anybody else hear her?
No. I can. Yes. I can. Oh, I thought you said you could hear you. Well, I can't.
Okay.
I can't hear her.
Okay.
No.
I can't hear her either.
Not you.
She unmuted. Yeah, she unmuted though before, and I couldn't hear her, so I just wanted to know. So Manya, it seems like we can't hear you, so you might want to join. You might want to leave the meeting and rejoin. So.
Can I do the next
Middleish, you? Is that you?
Yeah.
Okay, yeah, you can do that. You can do this one.
Yeah.
So what you're doing in this problem is you're trying to solve for y, basically.
Okay. Can you hear me now?
Yeah, we can hear you now.
We can.
Okay, Middleish, can you tell us what you're doing?
Okay, yeah. The y would be equal to 5 that's going to 5 2.
What? So it's supposed to look something like this. See, this is a multiple choice question, so it's a little bit easier.
So it would be y equal to 3 times plus 5.
Yeah?
Negative.
Okay, so you're correct so far, but it's actually a positive 4, because if you want to cancel this 4, then you're going to have to add 4 to both sides, so that it cancels this 4, because this is a negative 4, so if you want to cancel it out, you want to add a 4 to both sides, and that's going to make there be a positive 4 over here instead of a negative 4. So the answer is this one.
Why do you do this just like that?
Where?
You on the side like you did it like this. Why'd you do it like that?
And it just happened like that. Okay, so who's next? Let's see. Who's next? Neil, you can do number 10.
Number 10. On a separate two-dimensional graph, the parabola behind the Directrix.
Yeah.
Okay.
You don't need to graph it.
We basically have to figure out why.
They already have it figured out for you. That's not what you're trying to do. They told you to figure out the directrix.
What's the Directrix?
Well, if you want me to go to the slides, I can do that.
What do you mean?
If you want me to go to the slides from yesterday, I can do that. Okay, so
I wasn't here yesterday.
you weren't? I'm pretty sure you were. I think I saw you. Okay, well. Oh, I think it's loading. There was a class yesterday. Okay, this is loading a lot. Just a second, guys. Not yet. Okay, when it's 8 o'clock. We're close to that. I mean, it's pretty close to that right now, but it's not time for a break yet, I don't think. Okay, I don't know what's happening anymore. I'm just gonna refresh the page. Okay, finally. Okay, sorry about that. I think I was having some technical difficulties.
Why is it looking like a lot?
Because I'm sharing the screen on the Zoom, and I'm sharing my screen for the live stream. Yeah.
That could literally be watching this on YouTube.
I mean, yeah, but I won't be looking at the chat, so I can't really respond to you, and you can't really participate. Okay, so this is.
How do you that much subscribers?
Okay, Neil. You told me to go to the slides.
Yeah, I don't know whatever. Yeah,
Well, it's this. It's right here. This is the equation for a directrix. This is also an equation for the directrix, but this is only if the equation has a x equals to something. But in your case, you have a y equals to, so you don't have to worry about this whole thing.
yeah, why? That's called a vertical parabola.
Yeah, parabola. So the directrix is this line right here, and you're trying to find the equation for this line. And how you do that is through this formula thing. So do you need me to go back? Did you write down the formula? Or did you look at the formula? Did you write down or look at the formula?
So it's basically x is equal to basically another variable minus a fraction.
It's y is equal to k minus 1 over 4a.
Does it always have to be 1 over 4a?
Yes.
And does it always have to be? And okay. So it always has to be.
Okay, excuse me. Oh, oops, I didn't mean to close that tab. Okay.
How many tabs do you have open, bro?
A lot.
Like, what is?
You should close tabs that you're not using because they take up
They're
Wi-Fi.
internet. They're stealing the internet. That's why you have a bigger, issues.
Okay.
Those are the ones that you're not using. Like, I see something that says L, L. I see two things that are saying L. Yeah. I'm pretty sure that means algebra.
It does. Okay, but let's get back to.
Website.
I didn't find it. Okay. Okay, so Neil, you're doing number 10, right? Remember?
Okay. So that. So y. So this one. So y is equal to. But what variable? So okay, k. Because I was forgetting that what like, so what variable do I have to put that y is equal to first? Like, should it be k or something like that? Okay, a. I have to put a.
And that's
You're muted.
plus. Oh, I am? Are you sure?
Okay, my question is. You're not muted.
Okay.
He was muted. Is that a 2 or a R?
Where? Oh, yeah, this is a 2. This is supposed to be a 2. Yeah, it doesn't look very much like a 2. 2. Okay, there we go. That's a 2. So, Neil, this is the vertex form equation for quadratic. Oh, sorry, this is the vertex form for quadratic equations, and this is the k variable, and this is the a variable. So you're supposed to put these in here, and in their respective spots. And if you look closely, this is structured the same way as this. So basically it's in the same form. So maybe you can like take that hint and stuff and try to solve this problem thing. Okay? Yeah, it's really not that hard. Okay, Neil, I think it seems like you need some help. So basically, the value for k, see the thing I underlined right here is right here. If you look closely, see this is a because because this is in the exact same spot as this a right here. So this must be a, and x stays x because x and y don't change, and h is this because it's in the exact same spot as h. Sorry, that's k. This is k because it's in the exact same spot as k over here, and this is and h is over here. This is h. So basically, all you need for this is this one and this one to find the directrix. So this is k. So you can have y equals 5 because we know k, and you can just substitute 5 for k because k is 5. And this is a. A is negative 1 over 8, so you can have minus 1 over 4 times negative 1 over 8. And now you can simplify this. This gets cancelled. This becomes a 2. And in the end, after we do all that stuff, we have y is equal to 5 minus 2, which is 3. Sorry, not 5 minus 2, it's 5 plus 2, so that's 7. So I need to erase this, and then I can write 7. So in the end, you have y is equal to 7. Okay, so this is really not the value of y. Okay, so this is the directrix. This is not the solution to this equation. We're not trying to solve this equation. This is just for graphing, okay? So this equation right here is not an actual equation.
But I mean, if you found y, you could figure out x too, right?
Well, not really, because this is a quadratic equation. You're gonna get infinity, I'm pretty sure. Because this
Isn't
is...
it break time?
Okay.
Yeah, I guess, yeah, you can have break time right now. 5 minutes, I guess.
Stop. Stop.
Did somebody say something? I couldn't hear you. Actually, you know live stream people can hear you, right? They can also hear me right now. Okay, so I'm gonna mute it. So see you in just a second.
over?
Yeah, it breaks over. Yeah. Okay. So let's unpause the screen share. Okay. So let's leave this parabola stuff here, and let us go on to some circles, which are considerably easier. Maybe. I don't know. I haven't checked. So let's go on to circles, okay? You know, we've been doing parabolas for a long time. I think we should go on. I think we should treat ourselves to some circles. Sweet circles. Okay, so let's take this and okay, so this is pretty difficult still. I guess we'll just do the easy problems. Okay, so let's get started. So let's do number 2. I'm gonna do number 1, but I'm gonna change it up a little. I'm gonna just rewrite this equation. It's still gonna be the same equation, but it's just gonna make it easier for all of you to understand, because yeah, it is. So we have x squared plus 16x plus 64
Could simplify.
plus 64 because of some algebra magic. I really don't know how to explain it. You have 64 because you're dividing 16 by 2 and you're squaring that number, so you want to add 64. And you want to also subtract it. So we can pair this up, we can group this up right like that. And we also have the y stuff, so we have plus y squared is equal, sorry, not is equal to, y squared minus 4y. So we have to divide negative 4 by 2. That gives us negative 2. Negative 2 squared is 4. So we have plus 4 here.
Why you divide it by 2 and then square it?
Because I don't know exactly the reason why. So what you're trying to do is you're trying to create a perfect square, which you can then factor out to be. So this factors out to be x plus 8. That's x plus 8 squared. That's why you want to divide this by 2 and square it, because you're gonna add that number over here. So then you can like make x plus 8 and square it. And then you can also do the same for this now, because we have that, but instead of positive 2 we're gonna have y minus 2, because this is a negative number. So we have y minus 2 squared. So now we can worry about like the equality of this and stuff. So the first thing we're going to do is add this to both sides. So we're going to have to add 64 plus 4. That's 68, right? So now we have 68 on this side. And we have to add 11 to this, because 11 is right here, and we need to bring it to this side. Okay? So 68 plus 11 is 79. 79. And now on this side, we have 79. So now this question is asking us to find the center of the circle. So obviously the center, if we go into this thing, the center obviously is so obvious. Sorry, I'm just trying to zoom in. It's not working. Okay, yeah, it's not working. I'm just going to present the screen. So the center is h comma k. So the equation of the circle with center h comma k. See, that says that the center is h comma k. So, and as you can see from this equation, the h is -8 and the y is +2. So, sorry, the h is -8 and the k is +2. That is because over here in this equation, there's a negative over here, and over here it's a plus. So to make a negative a plus, we have to multiply it by another negative. So this is going to be a -8 because we're replacing this with -8, and so when you replace h with -8, there's a negative. So there's a minus negative that becomes a plus. Hence, this is -8. We replaced h with -8. So the value of h is -8, and the value of k is 2 because we replaced it with 2. So Neil, what are you trying to say?
So I'm trying to see that. Should we rejoin because like you only have like 8 benefits that we have left?
Yeah, you should rejoin once the meeting ends. So this one is a little bit easier because it's basically already done for you. All you need to do is get it into like this form, and I'll give you a hint for that specific equation. H is 0 and k is 0. You just need to know the radius now. We already know this is 0. And remember, here's another hint: that anything plus 0 or anything minus 0 is still that same thing. The thing doesn't change if you add or subtract 0 from it. So let's see who this victim should be. Okay, so let's see. Middleish, how about you do this one?
Yeah. So this I'm kind of confused, but I'm gonna try. So R would be 36.
Okay, why? I'm not saying you're wrong, I'm just asking why. How did you get 36?
So I know that 2 times 2. So X I can't see it.
Can you see the screen? This is the equation for a circle. Can everybody see the screen?
Yes.
Yes.
Yes, we can.
Okay. So yeah, that was the equation for a circle. So to get this into that equation, basically we need to do x squared plus y squared equals 36.
So x2 squared plus y2 squared equals 36.
Yeah, so what does r equal? We know that r squared equals 36, so what should r equal?
0.
It's going to equal 6. Because if we know that r squared is equal to 36,
And the square root of 36 is 6.
yeah. Then we have to square root this side to cancel out this squared sign. And the square root of 36 is 6. So yeah, good job whoever said that. And good job, Midlish. So find the center of the circle whose equation is, okay, no, we're not going to do that. Okay, so this one should be easy. Which equation is shown by the graph below? And each of these things is 1 unit. So yeah, just remember that. It's not numbered, so. So let's see. Let's get the old participants list out. So Siddharth, how about you this one?
Okay.
So can you tell us what you're doing?
Is the equation x minus y squared? Wasn't the equation you showed us in the slide?
Okay. The battery is running out. Just a second. I'm gonna go back to the slide. Okay. Here. There's the equation.
Okay.
So, but first, let's look at the properties of the circle, of this circle. So, the center is right here. Yeah, what's the coordinates of the center?
0, 0, 0.
Yeah, the origin. Good job. What's the radius is obviously 3, right?
Yeah.
Yeah. So with this information, we can write this equation. So obviously, so what do you think the equation is?
So it's x squared plus y squared equals 36.
No,
Not 36. That's it.
It's 9, because 3 squared is 9. Remember, 3 times 3.
Yeah, I actually multiplied it by 2.
Yeah.
I keep getting confused with, yeah.
Yeah. Okay. So, yeah, this is the equation. Yeah, good job. But these are the things. Yes, there is one right answer. So, which one of these do you think it is?
It
So,
can't be the first one. It can't.
No, the last one.
It's the last one, yeah.
okay, Siddharth, what do you think? Just
Either the first, second. Oh yeah, it's the second.
okay. Yeah, good job. It is the second. It's because
Because to multiply the 9 by 2, which gives you 18. If you do it the one side, you add the other side, and we multiply those by 2, you get 2x squared and 2y squared.
yeah, good job. Yeah, that's exactly why it's this second one, or B. So yeah, good job. Good job, Siddharth. Let's go on to the next question. Find the center and the radius of the circle with the following equation. Okay, no, we're not gonna. Okay, so that's 80. Okay, so I'm just gonna. Okay, so I'm not gonna do anything to this equation, but let's see. One second. Okay, I know you weren't here yesterday, but can you just try doing this? This one? Number 5? Hello, Akil? Are you here? Okay, I don't think Akil is here. Or he left the meeting, I think. He is having problems. Okay, so let's go on to... okay, Manya, can you do this one?
Yeah, 1 second.
Okay. Are you solving it? Can you tell us what you're doing while you're solving it? Your voice has very low volume. So I can't.
It says that the meeting will end in 5 seconds.
Oh, okay. So everybody rejoin once it does end. I need charging. Charging. Okay. Let's open up the Zoom. Okay, everybody should be about back now.
Hello again, everybody. Hello. Hello, can you hear me? Hello.
Yes, Ingrid.
Do you know where the glasses theater is?
Hello?
Yeah, we are.
I can hear you.
Let me just share my screen. Okay, can you guys see the screen?
Yeah, we can see your screen.
Okay. Okay, so
Oh, the equation and then tell you how I did it.
Can you tell us what you're doing while you're doing it? Hello, Manya. Can you tell us what you're doing while you're doing it? Are you doing the problem? You're doing number 5, yeah? Right?
Yeah, can you hear me?
Yeah.
I'm doing the problem.
Okay. Yeah, we can hear you now.
Wait 1 second. I have to get the plug for my computer. It's gonna die.
Okay.
Okay, I'm back.
Okay.
I'm just dividing everything by 3 right now.
Okay.
One side of this equation and the other side.
Yeah, that's a good move. So 243 divided by 3 is actually 81. You don't need a calculator to do this because 24 divided by 3 is 8 and 3 divided by 3 is 1. So you don't really need a calculator to do that.
Plus x squared.
It's actually minus h squared. Manya, we can't hear you. We can hear you a little bit, but it's not. I don't think your microphone is picking up that well.
Can you hear me?
Yeah, I can hear you now. That was loud.
Okay, I have to yell.
Okay, so yeah, the center is 0. What do you think the radius is?
square root of 81?
Yeah.
Yeah.
Yeah, it's the square root of 81. It's 9.
Yeah. Okay, thank you.
Wait, does the center of a circle always have to be 0, 0?
What? You were cutting out. I couldn't really understand what you're trying to say.
Oh,
Yeah, me too. Okay. Yes.
I asked if the center of a circle. I asked if the center of a circle has to be 0, 0.
No, it doesn't. Not necessarily. See, this first equation right here, it had a center of -8 and 2.
Oh.
The center of the circle doesn't necessarily have to be 0, 0. Okay, this one seems easy. So, Neil, you can do this one. Hello, Neil? Can you hear? Are you here? Okay, it seems like a no. So we're going to move on to Akil, you can do this number 8. Okay, it seems like Akil is not here either. So how about Sri Lakshmi? Sri Lakshmi, you can do number 8. Sri Lakshmi. Okay, so let's see. So who wants to do this? Raise your hand in the the reactions or whatever in the participants list. I'm pretty sure is where it is. Okay, so David wants to do it. Does anybody else want to do it? Are you sure nobody else wants to do it? Okay, then Siddharth, you can do it.
Okay. So to find the radius, isn't it 41? The square root of 41. So the radius would be 7. And I think the center is -11, 0.
It's actually 11. It's actually positive 11 because, do you know why?
No.
It's because, see here, this is x minus h. So basically, you're substituting a positive number to keep this minus. If you
Okay.
substitute a negative number, then this would become a plus.
Okay, yeah.
Yeah, good job, Siddharth. Okay, so same procedure. And so who wants to do this one? This one is also easy. So if you want to do number 9, raise your hand in the participants list.
Raise your hand in the participants list.
I'm pretty sure it's in more.
You have to click on the participant thing on your lower screen, and then after you click on that, it shows the participant list, and at the bottom it shows you 3 options: invite, mute, and raise hand. You have to raise hand.
Okay, it seems like Siddharth is still the only one who. Okay, let's go on to Manya then. Manya, you can do number 9.
Okay. Do I need to tell you how I do it when I'm doing it, or can I do it?
Can you tell me what you're doing while you're doing it? I can't hear you. We can hear you a little bit, but it's not very loud. You might have to shout in the microphone again.
Can you hear me now?
Yeah. Okay, we can hear you.
Okay. We're gonna find the square root of 64, which is 8.
Yeah, good job.
Write down the formula so I don't forget it. Vector is not going to be the origin, right? It's not.
No, yeah, it's not going to be 0, 0. What? I couldn't hear you.
Hey.
What did you say? Yeah.
I didn't hear either.
I think she has to shout again. Okay, yeah, we can hear her now.
Okay. We can't hear you, but the center is actually negative. Okay, oops. It's actually -8 and -1.
Yeah, because
Did you get that? Did you get the same thing?
Yeah, I did.
Okay, good job, Shoptic. So it's 8:30. 30 minutes of class still left. So let's stop doing
I
circle.
think we've done the 10th one, haven't we?
What?
It looks like we've done this 10th one before.
It looks the exact same as this one. Yeah, it's I'm pretty sure it's not going to be the exact same answer though, but it's going to be the same principle basically. Because see, yeah, this is the answer. Because if you divide everything by 3, then it becomes x squared plus y squared equals 9, and that's the equation of this circle. So yeah, let's stop doing circles for now. Let's go on to something else like ellipses, which is harder than parabolas. I'm pretty sure. I don't know. So
or in ellipses, there's 3 dots.
Ellipses, I'm pretty sure those are the 3 dots. 3 dots. I don't know. Oh, okay, the ellipses, like, you mean like dot, dot, dot? Yeah, I'm pretty sure that's ellipses, but this is ellipse, which is like a stretched out circle. That's basically what ellipse is. And the plural of ellipse is ellipses. So, yeah.
A stretched out circle and oval.
Yeah, but like the technical name for it is an ellipse. If you want to sound like you're super smart, then you should call it an ellipse instead of an oval. Okay, so let's start off with number 1. Write the equation of the ellipse in standard form. We're not going to do that one. Let's go on to something a little bit easier. Okay, here, this one's good. Find the foci of the ellipse. So the foci is plural for focus. So yeah, yeah. So let's look at the thing, like this thing. Let's look at the Google Slides for ellipse. Come on, I'm trying to zoom out. It's not working, I don't think. I might have to reload the page. Okay, there we go. Okay, equation of an ellipse. So this is the equation of an ellipse, and that's it. There's nothing special about it. Not very much special about it. Okay. Okay, there we go. Oh, come on. Okay, there we go. So this is the equation for an ellipse. Okay, so it's basically the same. Yeah, both of these are basically the same thing. So this is the equation for an ellipse, and how you find the foci is you have to, well, you have to zoom out. I'm trying to zoom out. I don't think it's working. I can't get it to work. Okay, there we go. Okay, there we go. So let's go on to ellipses. Yeah. Oh my gosh. I can't seem to get this to work, so I'm just gonna close. I'm just gonna duplicate this tab. Okay. Okay, this does not seem like it wants to work. Okay, there we go. Let's hope that it doesn't pop back. Okay, there we go. The equation for an ellipse is right here. This is the equation for an ellipse. So this is basically it. That's the equation. And how you find the foci is, how you find the points of the foci is you have to, basically you have to, oh, come on. Okay, so basically what that said was C. Okay, let me take white. Okay, so that said C squared is equal to A squared minus B squared. So this is obviously derived from the Pythagorean theorem, but it's like different. It's like A squared minus B squared is equal to C squared, and that's how you get the value for C squared. And with this C squared, with this C value, with the value of C, you're supposed to subtract it from like the K. You're supposed to subtract and add it to the K, and that's how you find the coordinates for the two foci points. Okay? So yeah, that's how you do it. Okay, so let's try to use this technique on number 3 right here. Okay, so we're gonna get the drawing tool, we're gonna underline this, and then we're gonna look at this, find the foci of the ellipse. So it's telling us to find the foci, so what we have to do is we have to do 10 plus 46, because you have to remember that this is A squared by itself, and this is B squared, so we don't need to square this anymore to get it to do the Pythagorean theorem thing, like A squared minus B squared is equal to C squared. There's a B squared right here. So yeah, this is already squared, so if we add these two, it's going to be 56. And it seems like we did something wrong already. So I think we did something wrong.
You have to
Because
subtract 46 minus 10.
oh yeah, thanks for rounding me. That's 36. Yeah, good job, Siddharth. Yeah, thank you, Siddharth, for reminding me that this is subtraction and not addition. I was thinking of like the normal Pythagorean theorem, but we're supposed to do 46 minus 10 in this case. And that's 36, obviously. Square root of 36 is 6. So now you're supposed to add and subtract 6 to the center. Major focus line. Sorry, the major axis. Or the major whatever. Okay, so what you're supposed to do is we're trying to find what. Okay, so obviously it's negative 12 plus, sorry, it's a negative 12 comma 1 and negative 12 negative 11. That's what the thing is, because as you can see here, the x value or the x coordinate is 12 and the y value or the y coordinate is 5, and these are the coordinates for the center. And so when you do 5 and then you have to do 5 or negative 5 plus 6, so that's basically 6 minus 5, that's 1. And you have to do negative 5 minus 6 or negative 5 minus 6, which is negative 11. So yeah, that's why it's negative 11 and 1 with 12 as the x coordinate, because negative 12, sorry, is the x coordinate. So yeah. So the answer is negative 12, 1, and negative 12, negative 11. So yeah, that's the answer. Let's find another easy one, and let's do that one. Okay, find the lengths of the major and minor axes. Okay, so the length of a major axis, so the length of that is, what you have to do to find it is you have to divide, so you have to take the square root of the A and the B, and you have to, so first you have to square root these, and then you have to times 2 that, so you have to multiply that by 2. So let's see who's going. Raise your hand if you want to do this one, because this one's super easy. So Manya wants to do it. So so nobody other than Manya and Siddharth want to do it? Nobody else? This question is super easy, so anybody can do it. I'll help you through it. Okay, it seems like a no. So I guess Siddharth, you can do number 7.
Okay.
Can you tell us what you're doing? Hello, Siddharth, you muted. Can you tell us what you're doing while you're doing it?
Oh, sorry, I was talking on mute.
Yeah.
So what I was saying, so you told us to square the bottom numbers and then add and then multiply them by 2. So I squared 54.
You're supposed to.
He's like glitching or something.
Yeah. Your internet connection may be bad, but I told you to square root it, not square it. Don't square it, because if you square it,
root it?
yeah.
Oh, okay.
Yeah, Satvik, what do you have to say?
I think it's 6 and 16. I got 6 and 16 after I did it.
Okay, yeah, good. Those are the correct answers. But so the major axis is the bigger one, so obviously that one is 16, and the other one is 6. So good job, Siddharth. So yeah, let's So, Satvik, I think you had something to say? Or was it nothing?
I was gonna say the answer.
Oh, okay. Maybe you can go for this one, Satvik. Maybe, do you want to do 9?
Oh, what?
Do you want to do number 9? This one is also pretty easy.
I don't know how to do that.
It's just telling you to find the center of the ellipse. That is h, comma k, and that's just -12 and -2. Because of this equation, if you look over here, it says x plus 12 and y plus 2. So obviously, if you just multiply that by -1, if you multiply both of those by -1, you get your answer, or your coordinate ordered pair thing, whatever you want to call it. Yeah, it's pretty easy. It's not that hard at all. So let's go on to hyperbolas. No, they're not hyperboles, which are basically like exaggerations in English, type of figurative language. But that's not what we're talking about here. Here we're talking about hyperbolas, which are basically like two parabolas that are like flipped around each other, kinda, if you know what I mean. So this is what a hyperbola looks like. Let me show you a picture. So hyperbolas, you have scroll down here, and this is what a hyperbola looks like. It's like a sideways parabola on its side, and then another sideways parabola on this side. And yeah, hyperbolas are really complicated and stuff, but I'll handpick the easiest questions for you guys to do. And we only have like 10 minutes left, so we're about to done. So if you want to get picked on, then this is your last chance. We're just gonna do 2 or 3 questions from this, maybe even just one. So I'm just gonna do an example problem. Ooh, looks like I never finished this. Well, let's do stuff that I did not finish. Okay, here. Find the slopes of the asymptotes for this hyperbola. How about not? Find the foci of the hyperbola, find the vertices of the hyperbola, blah blah blah, find the slopes of the asymptotes. Okay, looks like we're gonna have to do the slopes of the asymptotes, just like we did before. Okay, so the slopes of the asymptotes are pretty easy, if you ask me. But I'm pretty sure you're not gonna ask me. I don't know. Maybe you will.
What are asymptotes?
So asymptotes. Okay, here let's go back to the slides. So I went into more. I went more in depth on asymptotes in the yesterday. So if this wants to behave, okay, I don't think it wants to behave. So at least we can. So basically, how you get the slopes of the asymptotes is okay. Oops.
Wait, can you guys see me?
No.
Okay.
Wait, I think so. I don't know. No, I don't think so. Okay.
Can
so
you see me now?
yes.
Yeah, we can.
Okay.
Okay. So these are the slopes of the asymptotes. So what asymptotes are is like, basically, here, you can just search it up. So asymptotes. So if you look up the Google definition for asymptotes, so in analytical geometry, an asymptote of a curve is a line such that the distance between the curve and the line approaches 0 as one or both of the x or y coordinates tends to infinity. So that's just a really complex way of saying that the curve gets super close to the asymptote, but it never actually reaches it, even as it goes to infinity. it never reaches it. It just gets closer and closer, and it gets even smaller than the Planck length. It just goes closer and closer, but it never actually reaches it. So that's what asymptotes are. And the asymptotes are those the hyperbola. And it's asking you for the slopes of the asymptotes, and for horizontal, transverse axis hyperbolas. That's gonna be this first one right here. And the transverse axis is like the vertical axis, so to say. It's the axis going through it's the axis going through the focus, and it's like this axis, okay? So let me get my drawing tool. So it's this axis right here. I didn't mean to draw it like that. But this is the axis. Okay, that just looks okay. Whatever.
So is that the transverse axis?
Yeah, that's the transverse axis. Yeah, you're right. So here, let me just scroll on my screen. So this right here is the transverse axis line. This is the other line, and these two lines right here, these are the asymptotes. See, that one was an asymptote. This is also another asymptote. Yeah, it just gets closer and closer to this line, but it never actually reaches it. So
so they're asking you the slope of that?
Yeah, they're asking you the slope of that. And you can get that by this equation right here. It's b over a and negative b over a. So if you go into here, and yeah, there we go, and you clear the screen. So it's asking you for the slopes of the asymptotes, and that's, let me just write it down. It's b over a and negative b over a. And b and a are these ones. The smaller one is b, I'm pretty sure, and the bigger one is a. So you see this one? This one is a, this one is b.
Which one is B and which one is A?
This one is a, this one is b. The bigger number is a squared, and the smaller number is b squared.
Okay.
So you want to do this one? Whoever was just talking, do you want to do this one? It's pretty easy. It's not that hard at all. Who was that? I think that was Satvik or Surlakshmi.
No, it was not me.
Oh, okay. So it was Rohana Tavisa. Okay, so do you want to do this one, Rohana Tavisa?
I think it's the second one.
Okay, so well, let's see about that. It's 6 over 8 and negative 6 over 8, but when we simplify this, it becomes 3 over 4 and negative 3 over 4, and yeah, it is 3 over 4 and negative 3 over 4, so it is the second one. So good job, Rohana Tavisa. I think that's going to be the last problem that we do today. So see you all tomorrow. Bye.
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 Okay, see you all tomorrow, and I hope you have a good night, I guess.
You too.
Yoy.
So you know it's still recording the live stream, right?
I know.
Good. It's gonna be on YouTube forever.
Okay.